It perhaps is the most important question that any person can ask themselves. Any idea what that question might be?
Somewhere between why are we here and is there a God?
That's a great suggestion. Great contribution. Anybody else?
What's it about?
What's it about? Anybody over here? What's our purpose? Kids? Any thoughts? Well, I think the question that perhaps is the most important question anyone can ask is, why am I here? Why am I here? And if you ask me that question tonight, why am I here? I'll tell you it's because of biochemistry. Biochemistry is why I'm here. Now, I don't mean all the chemical reactions that are taking place inside the cells in my body that make my life possible, make my physical existence possible. And by the way, those chemical reactions are happening in your bodies as well. But that's the type of answer I would expect from somebody who is an atheist, who thinks that all the universe, that all of reality is just the universe itself. And to think that all we are as human beings is just the sum total of the chemistry that's happening in our bodies. No, what I'm talking about is the discipline of biochemistry. So do any of you kids know what biochemistry is? Some of you, maybe? All right. Well, chemistry is the study of matter, right? So chemists are interested in what are the atoms and the molecules that make up matter, right? And then how do these atoms, how do these molecules change? And you know, what interesting things happen when they change. So a biochemist is studying the chemistry of life, studying the matter that makes up living systems. What are the molecules that make up living systems? What are their structures? How do they undergo changes? And then how does that relate to higher order biological processes? How does that contribute to life? But it's my study of biochemistry when I was a graduate student that convinced me that God must exist, that life must come from the work of a creator. And once I realized that was true, that set me on a path that led to my conversion to Christianity. Now, I didn't grow up in a Christian home, and I didn't have Christian influences in my life as a young person. And in fact, by the time I graduated high school and went to college, I was an agnostic. I didn't know if God existed, and I honestly didn't care. There are other things that were much more interesting to me than the God question. And in fact, I was a bit of a geek then, a bit of a nerd, and I decided that I thought biochemistry was cool, and everything I did was focused on getting ready to go to graduate school to become a biochemist. So I took courses in chemistry and biology, and in those courses, I learned from my professors that the origin and the design and the history of life could be explained through evolutionary processes. That evolution could explain everything in biology, and if that's the case, then I reasoned that why would you need God? If everything in biology could be explained by evolutionary processes, what role is there for God to play? And in fact, I meet so many young people. In fact, I meet a lot of adults who have that very perspective. If evolution can explain everything in biology, why do we need God? And that's the view that I held. When I went to graduate school, things changed, though, quite a bit for me, because I began to study in detail biochemistry. And the more that I learned about biochemical systems, the more I was amazed, because these were incredibly elegant and sophisticated systems that just displayed this ingenuity. And I wanted to know, how do we explain as scientists where these systems come from? This is called the origin of life question. And I didn't want the explanation that I had as an undergraduate student, evolution did it. I wanted to know the details. I wanted to know the specifics about how evolution produced the very first cells. And as I began to study that question, I quickly came to the conclusion that there's no way evolutionary mechanisms could explain the first cell. And because they're so elegant and sophisticated and evolution couldn't explain them, that to me suggested there had to be a creator that was responsible for bringing those first cells into existence. That caused me to ask some very important questions. Who is this creator? How do I relate to that creator, if at all? And as I began to think about the answer to those questions, I started going down a path that's called universalism, where I thought, well, maybe the different religions of the world were different ways that this creator tried to communicate to human beings. And as I looked at the different religions of the world and saw that they taught more or less the same thing from a moral standpoint, I thought, well, maybe this is true. Now, that was an extremely naive view that I held, because I later come to appreciate the fact that the different religions of the world teach very different things about the nature of reality, about the nature of God. And so they all can't be true. Either one is true and all the others are false, or all of them are false, but they can't all be true. And in fact, in a few weeks, when my friend Ken Samples is here, he'll talk about that idea in more detail. Along the way, I met a pastor who ultimately married my wife and I. His name was Johnny Withrow, and he challenged me by asking me, have you ever read the Bible? And I said, no, I hadn't. I was 23 years old. I never had picked up the Bible. And he said, well, how do you know that what's in the Bible isn't true if you've never read it? That's a good point. So I got a copy of the Bible. I began to read the Gospel of Matthew. And when I read through the Sermon on the Mount, I encountered the person of Christ. Here Jesus is teaching his disciples how to live an authentically righteous life. And I looked at what he taught and I thought, this is true. I want to live my life that way, but I couldn't. And I recognized my sin. And one of Johnny Withrow's friends, who was with us that evening when we had a conversation, gave me a little booklet on how to become a Christian. And so as I read through that booklet, I realized that all I had to do was, first of all, acknowledge that I committed sins, that I was a sinner, that I failed, and that to recognize that it was through Jesus' death on the cross, my sins could be forgiven, and more importantly, I could be reconciled to God. Wow, that's crazy. The very God who I discovered as being responsible for bringing life into existence is a God that I could actually have a relationship with. So to me, that's still mind-blowing to this very day. So the point here is that it was seeing God revealed through the record of nature, through the world around us, through the elegant designs of the molecules that make up the cell, and it was through encountering Christ in the pages of Scripture that led me to becoming a Christian. But if it wasn't for, first of all, understanding and realizing that there was a creator, the gospel really made little sense to me. Because as an undergraduate student, I had friends who were Christians, and they would share their faith with me. They would share the gospel with me, and it just didn't have an impact on me. Because I wasn't convinced there was a creator. But as soon as I was convinced that there was a creator, now the gospel made sense when it was presented to me. And so that's the first thing that we need to do whenever we engage someone who isn't a Christian, who isn't a believer, is to help them understand the reality of God's existence. And when it comes to science, we see a lot of powerful evidence from science that points to the reality of God. And this is very much the case when it comes to biochemistry. Now, I'm a scientist, and in science, you'll learn that any scientific conclusion is considered to be provisional. It's true today based on what we know, but it may not be true tomorrow if we discover something that maybe overturns that idea. So ideas in science you hold very loosely. And so I reached the conclusion 35 years ago or so that there must be a creator based on the design that I saw in biochemistry and problems with the origin of life. And so the question is that conclusion still true today? So the last 35 years, I've gone back to that conclusion time and time again, testing it. And I can tell you that today, that conclusion is stronger than it was 35 years ago. But there's something else, too, is that 35 years ago, I had this intuition of design. When I looked at these biochemical systems, they looked like they were designed to me. And I meet a lot of people who, when they get exposed to biochemistry, it's very clear to them that there must be a creator that produced those systems. But the question is, can we show that to be true scientifically? Can we actually demonstrate that to be true scientifically? And so that's what I'm going to do for the rest of the time I have, is show you how we can make a scientific case for a creator from biochemistry. Now, what I'm going to do is use an approach that is used in certain areas of science. There are some areas of science that actually can detect whether or not intelligent agents have been involved in producing some feature of nature. For example, SETI. How many of you have heard of SETI, the Search for Extraterrestrial Intelligence? Right. So astronomers are pointing these telescopes at different objects in space, looking at the radiation, the light that's coming from those objects, and based on the characteristics of that light, they can determine whether or not that light is coming from an intelligent alien civilization or some kind of natural process. So in other words, they have methods that can detect intelligent agency. Or crime scene investigators, right? You know, if there's a body laying on the ground, these forensic scientists can study the body and study the scene around the body and determine, did that individual die from natural processes, or was there a malevolent, intelligent agent that was responsible for the death of that person? They can even tell something about what that person who brought about the death of that individual. They can tell something about them, their capabilities. Were they left-handed, right-handed? How big might they have been, right? And then last but not least is archaeology. Archaeologists can pick up a rock and study it and tell you, was this rock shaped by weather and erosion and other forces of nature, or was it shaped by a creature like Homo habilis or Homo erectus or Neanderthals? And again, all of these disciplines have the ability to detect the work of intelligent agency. And so what we want to do is look and see what they do and then model our study after them. And so to illustrate this, I want to talk about something called the Cerruti Mastodon site. This was an archaeological site uncovered in San Diego County, outside of San Diego, in 1992, I think, where a team from Caltrans was doing road work, and they unearthed this mastodon remains. And as a result of that, everything stopped, and they brought in archaeologists who studied the site. And it turns out they concluded that it looks like these mastodon remains were processed by humans. It looked like somebody had taken rocks and hit the femur, the long bone of the mastodon, trying to get the marrow outside of the bone, right? And they could see striations on the bone, striations on the rock that looked like, again, the rock hit the bone, but they couldn't date the site. They tried and tried and tried, and they couldn't date the site. Well, in 2017, they figured out how to date the site, and it dated at 130,000 years in age. Now, this was shocking to them. And the reason why it was shocking is because human beings were not in the Americas until about 15,000 100,000 years ago at the most. So here we had evidence for humans manipulating these mastodon remains about 120,000 years before we think humans made their way into the Americas. This is crazy for an archaeologist. And so these researchers had to make sure that all of their data was airtight, because they argued that the humans that were in the Americas were probably Neanderthals. That this is evidence that maybe Neanderthals were already in North America before we, modern humans, came to the scene. Now, what did they do? First of all, they demonstrated that the site was indeed processed, the archaeological remains were indeed processed by humans, by an intelligent agent. In other words, they looked to see if the site displayed what we could call artificiality, right? And they concluded that the arrangement of the mammoth bones and the arrangement of the rocks was unnatural. It wasn't what you would expect if this was through natural processes. And again, there are these markings on the bone and markings on the rock that indicated that somebody had hit the bones with a rock. They then wanted to rule out any kind of other explanation. Could there have been water flowing through the site that picked up the bones and redeposited them? No, they ruled that out. Was it maybe scavengers going into the site after the mastodon died and began trying to eat at the remains? No, they ruled that out. They even asked the question, could the arrangement of the remains be due to Caltrans and the heavy equipment that was used to unearth the remains? They ruled that out as well. And then last but not least, they went into the lab and they took the femur of a dead cow. They took the same kind of rocks at the site and they hit the femur with those rocks, trying to get the marrow out. And they produced identical striation patterns in the bones and the rocks. So they did three things. They demonstrated the artificiality of the site, they ruled out natural process explanations, and then they went into the lab and demonstrated what would it take to produce those same kind of features. So we can take those same three criteria and we can ask the question, do biochemical systems display artificiality? Can we account for biochemical systems through natural processes, through some kind of evolution? And then last, what does it take to create a biochemical system in the lab? So let's take a look first at artificiality. And to do this, we're going to take a look at something called the watchmaker argument. How many of you in here have heard of the watchmaker argument? George, if you didn't raise your hand, I would be very concerned. Well, the watchmaker argument is a famous argument for God's existence. And it was developed by this guy named William Paley in the late 1700s. He wrote a book called Natural Theology. And William Paley tells a story. He says, suppose that I'm walking along and boom, I kick something on the ground and I pick it up and I realize, oh, this is a rock, right? Well, then he asks the question, how did that rock get there? Well, you could probably explain the rock through some kind of set of natural processes. All well and good. Now, suppose I'm walking along and boom, I kick something and I look down and it's a watch. And I pick it up and I examine it. Well, I conclude something very different about where that watch came from. It must have come from a watchmaker. And so Paley asked why? Why do I have two very different conclusions? And his point is because when we look at the watch, we can see that it has these parts that fit precisely together and that they work together to accomplish a purpose. He called it a contrivance. I love that term, a contrivance. And so then Paley compares what was known about biological systems in his day with a watch and a rock, and he concluded that these biological systems look so much more like a watch than a rock, and so therefore, if a watch requires a watchmaker, life must require a watchmaker as well. And so we can take that as a test for artificiality. Does the watchmaker argument, or is it satisfied by what we know about biochemistry? And one of the things that I find really interesting as a biochemist is there seems to be this relationship between the technology we build and the designs of biochemical systems. I could give a whole talk on that. It's absolutely fascinating. But the point is that when we as human beings, like William Paley pointed out, when we create an object or a system or a device, those things that we make have certain properties that reflect the work of human beings, of intelligent human agents. And when we study biochemical systems, we see that the basic design of these systems, their defining features, are identical to the features that we would recognize as evidence for the work of a designer, of a human designer. In other words, when we look at biochemical systems, they have the same properties as a watch. And if biochemical systems have the same properties as a watch, then it's reasonable to think there must be a divine watchmaker. And on top of that, there are certain biochemical systems that in their totality bear this eerie resemblance to human designs. And I'm going to talk to you about one of them. This is a category of molecules inside the cell called molecular motors. These turn out to be these massive protein complexes that literally are designed to look like motors and function like motors. And there are hundreds of them that we could talk about tonight if we had the time. But we're only going to talk about one. And this is a picture of that molecular motor. This is called F1F0 ATPase, or ATP synthase. Now, I wasn't talking in tongues. I didn't have but this is actually just biochemical terminology. But this is a protein that is made up of other proteins. So it's a complex of proteins. There's probably 100 or so different protein molecules that are interacting to create this massive structure that looks and operates just like a motor. This is actually a depiction of what this motor looks like. This is what biochemists call a ribbon diagram, and this is called a space-filling model. So here's a cartoon of this protein complex, and it's embedded in membranes. So in our cells, we have these organelles called mitochondria, and in the inner membranes of mitochondria, these protein complexes are embedded in the membrane. There's this, let's see if I can get this to work. There's this part right here is like a pie-like structure embedded in the membrane. That's a motor. And there's channels in that motor that allow for the flow of protons. Protons are positively charged, and the flow of charge, the movement of charge, is an electrical current. So there's an electrical current that runs through that motor, and as it moves through the motor, it causes this rotor to begin to rotate. There is a cam that will then interact with these blue and green ovals. These are turbines, and it causes those structures to breathe, to move in and out like a turbine. And when it does that, that movement generates the energy you need to drive a chemical reaction that produces a molecule that then the cell uses to power its operations. So this is an energy-generating molecule that converts electrical energy into mechanical energy into chemical energy that can then be used to power the cell. Now, it's one thing for me to show you a picture. It's another thing altogether to show you a video of this protein during its catalytic cycle. This is actually a video created by a team of scientists who synthesized probably several thousand individual biochemical studies and took all the clues from those studies and then figured out how this protein moves during its catalytic cycle, and they created a video. So just watch the video and look at the machine-like nature of this.
These protons drive a rotation of the turbine within ATP synthase, resulting in the synthesis of ATP. Like all generators, ATP synthase consists of two separate motors coupled together. Within the membrane, we have the FO motor, named after the binding of antibiotic oligomycin. And at the top, we have the F1 motor from factor 1.
So isn't that remarkable? This is what this protein, this is a molecule that's behaving like a machine. Now, to me, it's interesting to see what atheists think of this particular protein complex. This is a guy named Nick Lane. He's a biochemist at University College London. And he wrote a book a few years ago called The Vital Question. And in this book, he talks about ATP synthase. And this is what he says. The most impressive nanomachine of them all, ATP synthase, is indeed a rotary motor in which the flow of protons turns a crankshaft, which in turn rotates a catalytic head. The protein works like a hydroelectric turbine. This is barely poetic license, but a precise description. Yet it is hard to convey the astonishing complexity of this protein motor. This is precision nanoengineering of the highest order, a magical device, and the more we learn about it, the more marvelous it becomes. Some see it as proof for the existence of God. I don't, but it undoubtedly is a wondrous machine. So the point is, when you look at things like ATP synthase, and this again is just one of hundreds of examples we could talk about, it looks like it's designed, doesn't it? It looks like it's, so artificiality, the artificiality box is checked. Now, the question is, can we explain where these systems come from through chemical evolution? Now, I'm not going to get into a lot of technical details. If you want those details, there's several books I've written on this. Origins of Life, Creating Life in the Lab. If you want to read all the chemical problems with chemical evolution, that's the place to go. But I'm just going to simply show you how scientists working in the origin of life have responded to the significant problems. Paul Davies, an astrobiologist, in his book, The Fifth Miracle, which is on the origin of life, said, "When I set out to write this book, I was convinced that science was close to wrapping up the mystery of life's origin. Having spent a year or two researching the field, I'm now of the opinion that there remains a huge gulf in our understanding. This gulf's not merely ignorance about certain technical details, it's a major conceptual lacuna." In other words, nobody knows how chemical evolution could have produced the very first cell. And people working in this discipline agree that's the case. Now, when it comes to trying to solve the origin of life problem, there are three fundamental approaches that origin of life researchers have taken. I'm not going to get into the details of that tonight. There's just three different approaches. And the bottom line is that these different approaches have all led to failure. They're just intractable problems. I'm not going to go into the details again, but Leslie Orgel, who died a few years ago, he was one of the premier origin of life researchers in the world, and he basically said this: it would be a miracle if a strand of RNA ever appeared on the primitive Earth. Metabolism first scenarios have all kinds of problems too. I'm not going to go into the details, but he wrote, metabolism first scenarios require an appeal to magic, a series of remarkable coincidences, a near miracle. And then a few years ago, I worked with a chemist by the name of Jackie Thomas, and she and I wrote an article basically that was published in an Origin of Life journal critiquing membrane first scenarios, where we pointed out a number of problems with them. So the bottom line is, we don't know how chemical evolution could have produced the very first cells. And this is universally accepted as being the case, even by origin of life researchers. So the second box is checked off, right? Yeah. Okay, third box, and that is, what does it take to create biochemical systems? Now, this is an area of research that's part of the Origin of Life research program, and it's called prebiotic chemistry, where scientists go in the lab and they try to replicate the different steps they think were necessary for the origin of life, right? With the hope that they can kind of reconstruct that evolutionary pathway. And scientists working in this area are very clever, very brilliant scientists who've developed chemical pathways for most of the building block materials and have ideas how these building block materials might assemble. So they've actually had some very interesting success in the lab towards establishing chemical evolution. There's one problem, however, and that problem is that what they do in the lab has no bearing on what happened on the early Earth. And the reason why I say that is because they go in the lab and they set up some kind of glass apparatus, and then they have these very carefully controlled conditions. These are chemically pristine environments that they set up, where they have a solvent with the just right solvent at the just right temperature, the just right pH that they very carefully control and manipulate. They add the just right compounds in the just right concentration with the just right order of addition. They stop the reaction before it goes too far, and voila, they can do some very interesting things. The problem is that on the early Earth, there's not organic chemists to oversee the process, right? The early Earth is this very complex environment where you don't have these kind of controls. And so this is called the problem of unwarranted researcher involvement, where Origin of Life researchers are now recognizing that this is a very serious problem. And in fact, they question whether or not 70 years of research in prebiotic chemistry is even relevant. And one of those researchers is a guy named Clemens Reichert, who wrote a paper a couple of years ago now called Prebiotic Chemistry and Human Intervention. And this is what he says: experimentalists in the field of prebiotic chemistry strive to reenact what may have happened when life arose from inanimate material. How often human intervention was needed to obtain a specific result in their studies is worth reporting. In other words, Origin of Life researchers unwittingly have involved themselves in the experimental design to the point where they actually are contributing to the success of the reaction. And they didn't realize it. They weren't recognizing this. Clemens Reichert says this in the paper: it's not easy to see what replaced the flasks and pipettes and stir bars of a chemistry lab during prebiotic evolution, let alone the hands of the chemist who performed the manipulations. And yes, most of us are not comfortable with the idea of divine intervention. Because once you start arguing that intelligent agency is needed, you now are making an empirical case for intelligent agency on the early Earth, generating the very first life. Steve Benner, who heads up a group called FAME, which stands for the Foundation for Applied Molecular Evolution, said this: one community of Origin of Life researchers revisits classical questions in prebiotic chemistry with complex chemical schemes that require difficult chemistry performed by skilled chemists. Their beautiful craft work appears in brand name journals such as Nature and Science. However, precisely because of this complexity, the complexity of this chemistry, it cannot possibly account for how life actually originated on Earth. And let me illustrate this problem by talking about something known as the RNA world. We don't need to know the specifics of this, other than the idea is that the very first biomolecules were RNA molecules. And some of you may know what RNA is, and it doesn't matter if you do or don't. But when in the mid-1990s, there are these famous experiments that were done where people showed that you could assemble RNA on clay surfaces from RNA building blocks. And they thought, wow, this is huge, because if there was clay on the early Earth, it could serve as a site where RNA molecules could be built. This was considered a huge advance in chemical evolution. Problem is that when you examine the studies, you see that, again, this was done under chemically pristine conditions. The reactions only work if you have distilled water, highly purified water, where you're adding the RNA building blocks. And this, of course, would not be the case on the early Earth. The early Earth would have an aqueous environment, a water environment, that would be loaded with all kinds of materials. In fact, materials that would interfere with the RNA assembly, or if the RNA assembled, materials that would cause it to break down. These reactions have to be stopped before the RNA molecules get too long, because if they get too long, they become irreversibly attached to the clay. You can't get them off. Now, if this happened in chemical evolution, it would be game over. That molecule is out of commission. And then last but not least, you have to buy the clay from a special supplier. You just can't take any clay off the shelf. And you got to treat the clay in the lab in a certain way for it to function as a catalyst. And then you have to use the RNA building blocks that you've chemically modified to make them highly reactive. Right? So Paul Davies said this: as far as biochemists can see, it is a long and difficult road to produce efficient RNA replicators from scratch. This conclusion has to be that without a trained organic chemist on hand to supervise, nature would be struggling to make RNA from a dilute soup under any plausible prebiotic conditions. Simon Conway Morris goes one step further. He's an evolutionary biologist, and in his book, Life Solution, he said, many of the experiments designed to explain one or other step in the origin of life are either of tenuous relevance to any believable prebiotic setting, or involve an experimental rig in which the hand of the researcher becomes, for all intents and purposes, the hand of God. So here's the irony. These experiments in prebiotic chemistry designed to validate chemical evolution have actually demonstrated the necessary role of intelligent agency to bring about the appearance of biochemical systems. But for us, we've been able to show that biochemical systems appear to be designed, that we can't explain them through chemical evolution, and that to create these systems requires intelligent agency. So when we put this all together, what we've produced is a scientific argument for God's existence. This isn't a philosophical argument. This is a scientific conclusion. This is exactly the same type of conclusion an archaeologist or a SETI researcher or a forensic scientist would arrive at if they had this kind of data. And so this is why I believe God exists. Or as George said, why I know God exists. I don't believe God exists, I know God exists. So anyway, I'm going to, excuse me, turn the floor over to you guys now to ask questions. But before I do that, I just wanted to let you know that just as a way to kickstart your journey into apologetics, we've got a gift for you, for all of you that are here tonight. If you go to our book table, or if you scan this QR code, we have a free book to give you. It's called Building Bridges, and it's a collection of essays that show scientific evidence, or the scientific case for a creator. And it goes from astronomy to biochemistry to biology to human origins. So anyway, that's a free gift for you, so please go to the book table and take advantage of that. But yeah, you're very welcome. And so now we'll just, I guess, go to Q&A.
Right. Isn't that awesome? Okay, so think about your questions, kids first. But I have a question for you. I have
Sure.
two. So, is it? I know. I'm letting them think, giving them some time. The biologists and the chemists, do you feel like they're not being honest with the evidence that they find in a lab? And I'm sure. And does that apply to the other disciplines as well?
That's a great question, and I think for the most part, scientists working in these areas are actually sincere. They're operating with in a particular worldview, right? In science, the philosophical system that kind of organizes work in science is called methodological naturalism. And so what that means is that whenever you investigate scientific problems, you always look for some kind of natural process explanation, right? And so you can't, God as an explanation is ruled out ahead of time. And so you're only looking for mechanisms. So origin of life, I've met and interacted with a lot of origin of life researchers over the years, and they're very, very honest, fun people to hang around with, incredible optimists, because they are confronted with all these problems in their discipline, and they just are optimistic that they're going to figure this out one day. So they readily admit we have no clue. They readily admit these kind of problems that we talked about. But they're absolutely convinced there's going to be some kind of chemical evolutionary explanation, because in part of the way they approach science, the only option is evolution, right? So it's not like they're dishonest, but they're trapped by their philosophical system, right? More so than the evidence, because all of these quotes were coming from people that are atheists for the most part. Yeah. I've known or interacted with some of these people, and they're atheists, except for Simon Conway Morse, who is a theist, by the way.
Oh.
So,
all right.
But anyway.
One for our team.
Yeah.
Okay, and then I have to know, when science led you to faith, how did your family respond to that?
Yeah, well, not very positively. My father died a few years ago now, but was a Muslim. And so when I converted to Christianity, that was not a good experience for me or him in terms of our relationship. Yeah, so, yeah. My mom was upset about it too. But I mean, she's later on in life, she came to faith in Christ, so.
Wow.
Yeah.
What about your friends and colleagues? Do they think you're crazy for...
Yeah, but it's not because I believe in God.
Enough said. Wonderful. All right.
There's a whole lot.
It's another story,
Yeah.
For sure. All right, guys.
This isn't really, this isn't a question. This is more of an observation, a comment to notice this sort of like poetic connection of where we are now versus when religions started, that the historical purpose of religion is to explain the world around us, right? So it's kind of funny that now we're here and we're using what we call science to now sort of, let's see, how do I put this? In the past, we looked to God as an explanation. Now we're trying to find an explanation for God. It's kind of funny.
Yeah. Yeah. Well, one of the things that you see in Scripture is this idea that God has made himself known to us, right? And so the Bible that we have is one way that God has revealed himself to us, because we believe that Scripture is inspired by the Holy Spirit, inspired by God, and then there are human authors that wrote it, but they are writing under that inspiration. But Scripture tells us that God has also made himself known to us through nature. And so science is the study of nature, and so we would expect that we should see God's fingerprints when we look at nature through the lens of science. And so the nature is really part of God's revelation to us, the way in which God's speaking to us, and letting us know that he exists, and even letting us know something about his character. And, it's also interesting to me that science is actually birthed out of the Christian faith. It's like it's like not only this idea that God is revealed through nature, motivated the early scientists who really began to investigate nature as part of their faith as Christians. It really flowed out of their faith. But even elements of the Christian worldview are critical for science, for the presuppositions of science. So, for example, in order to do science, you have to be convinced that there's regularity in nature, right? And that's something that Scripture teaches us, that there is a regularity, that there's order to nature, there are laws, right? Or that nature is even worthwhile studying. But something that I think is fascinating too is what you're assuming in science is that the universe is intelligible, and that as human beings, we have this wherewithal to understand the world around us. And so those ideas flow out of the notion that human beings bear God's image, and again, the idea that God is revealed through nature. So, in a sense, science is actually birthed out of Christianity, right? And so it's natural for us to go to science and see that as a deeply spiritual undertaking. So, to me, I think as a young person, a career in science is a calling. You should think of it as your ministry, right? And what you discover as a scientist is things that nobody knew about the world around you, and you're discovering something new about God when you discover these things. So anyway, that's probably more than
That's very good.
that's probably more than what you bargained for. I'm sorry about that.
All right. It's cool. It's cool, Fuzz. It's very cool, Fuzz. Okay, who's next? Oh, yeah.
I actually have several questions, but this one I think would sound the best on the mic. How do you feel about aliens? Josh made it.
They're a little scary, but no. No. I don't. My personal conviction is I don't think there are probably alien civilizations that are out there. I think there's some. And Jeff, my friend Jeff Zwerig, is coming in a couple of weeks. We'll talk about that. That's his whole talk, so you want to make sure you're here for that. But when we look at the features of Earth that make life possible, there's so many things that have to be just right that it's hard to envision another planet like the Earth in our galaxy, let alone even in our universe, that would have the properties that would be necessary for life. So that kind of makes it unlikely that aliens would exist. And we also, through SETI, have looked systematically, I think as far out as maybe 250 light years away, and have seen no evidence for alien civilization. So it doesn't look very good that there actually are aliens. But, if you think about this idea that God is a creator, and that's very much part of his nature, there's no reason why God could not have created other creatures throughout the universe as just part of his creative work. So, there's nothing inherently problematic about aliens existing in the Christian faith.
Pretty much like, why would an artist stop making art, right?
Yeah, exactly. Yeah.
Yeah. I don't know. I know it's just kind of seems like I've heard that people have said oh, evolution happened once and hasn't happened again that because the odds are so low, but the odds of it, or the first cell being born, that's
Yeah.
the odds of that kind of it's surviving, not just being formed, it finding something to nourish itself, just seems astronomically high.
Yeah. Yeah, I mean, that's true. I mean, it's, there's a whole collection of problems with that idea of chemical evolution, and that's just one of them is, and some people have the view that maybe we got lucky, right? That life, that among original life researchers, there's a debate. Is life extremely rare and it just happened by chance, here on Earth, and the likelihood of it happening elsewhere may be very low? Others think, well, maybe there's just something in the design of the universe that inevitably is going to lead to the production of life. So there's actually a debate even among origin of life researchers as to, you know, is the origin of life inevitable, or is it just simply a lucky happenstance?
I have just a quick comment. Couldn't one also argue that the reality of a creator is like itself like sort of like a thing by chance, not how do I put this? Sort of like further proving the creator thing. I don't know where I was going with that. As I was ready to ask the question, the words just kind of fell away.
Wait till you get to be my age. I'm lucky I can formulate sentences some days. Take a moment. You'll think about it when you're taking a shower tonight, but
It was really more of a joke than anything. One arguing that if we're only here because of pure chance, then one could argue that that you know, and all the possibilities of like you know, how the world is, that reality just happened to be. You see, it slipped away from me again. It's at this point, it's not funny anymore because it's taken so long for me to process this. So.
I feel your pain. It's like my sermons. Okay. All right. Any other questions, kids? Kids, any other questions? All right, big kids, raise your hand. I'll come and visit you. Jeremy.
I have a question on the biological motor. Was it F1, F2, or what was it?
F1, F0.
F1, F0. Have they tried to replicate that? And I'm just curious about the properties of it. Have they tried to replicate it? Kind of the efficiency. Are there any studies on that you know of, or?
Yeah, well, I mean, the efficiency of the motor is nearly 100%. So it's almost an ideal motor. And that's true for many of the biological.
So there's zero loss from energy to output ratio, and it runs on chemical electricity, or?
Well, electrochemical potential is what drives it. But yeah, you could think of it as as an electrical motor. Part of the reason why you have very high efficiencies is because there's no friction at the molecular scale, right? So that's part of the reason why you get. But these are very efficient systems, and nobody has even come close to trying to build this. There's an area of science called nanoscience, and nanoscientists aren't really tiny little scientists. They're actually scientists working to build these little tiny molecular scale devices. So people are trying to engineer, you know, devices at a molecular scale. It's pretty neat stuff. And one of the big problems is, how do you generate movement? How do you generate motion that you can control in those systems? And about 15 years ago or so, a team actually had the idea of taking these molecular motors from the cell and interfacing them to the nano devices they're building. And they used the ATP synthase as a proof of principle that they could actually isolate it and then interface it with a nano system and control its movement. So people are actually kind of incorporating it into their nano systems, but it's a real challenge to generate any kind of controlled movement in these nano devices. So that only makes this system that much more remarkable.
Yeah, I want to go home, learn more about it now. But one thing, too, that I thought was interesting is if you look at viruses, they're not living.
Yeah.
And they almost seem like they're nanobots in a sense.
Yep.
And they look almost so alien or so weird.
Yeah.
You just wonder. okay, these things are getting into us and
Yeah.
replicating their DNA inside of us. It's just so odd to.
Well, I mean, there are these like in a virus virus capsid, you have DNA. It's like the virus is basically a protein shell, and with DNA inside inside this shell, and then some viruses might have a membrane around it, but to get the DNA into that space is very hard, and there's huge amounts of pressure, right? And so there's a motor that will drive the DNA into the viral capsid head, and it's a really cool ball race system, right? So there's one that's been heavily studied called the T4 packaging motor. So if you're into this stuff, that you want to look that up too. Yeah, but viruses are fascinating. I mean, they're incredibly beautiful systems. The symmetry is just through the roof, and they just are amazing systems. They're like nanobots. That's a great way to think about them.
I was just looking at them and then
Yeah.
realizing that they're not living.
It's the aliens. Think of it as viruses again. Who's next? Oh, yeah.
Just getting back to your original question, which is, why you believe God exists. It just reminded me, you looked at the very small to approach that question, but this is more of a comment than a question, but Immanuel Kant, who was an 18th century philosopher, said he believed God exists because of the heavens above and the moral law within.
Yeah.
And I consider it to be very profound, because the heavens above are simply creation, God's creation, which demonstrates his fingerprints, and our intrinsic ability of knowing right from wrong. Where did that come from? Who wrote that?
Yeah.
And so just a comment that has always sort of stuck with me.
Yeah. Well, it's interesting because Paul in Romans talks about God being revealed through the creation, and that revelation is so powerful that people are without an excuse. And then he goes on to talk about even the Gentiles, when they behave in such a way that they adhere to the law, are operating on a law that God's written in their hearts, right? And Paul is actually quoting from Jeremiah when he says that. So, it's the same idea that Paul was saying, that we know God and we know what God expects of us because we've been created in such a way to see God in the universe, and to have that law written on our hearts. So yeah, great observation.
On aliens, could it be that these aliens are demonic spirits, things that the devil can appear as an angel of light? Perhaps they come from the center of the earth. As Revelations, all kinds of nasty things are going to come from the center of the earth.
Yeah. Well, you should, if you're interested in this, you should take a look at a book called Lights in the Sky and Little Green Men. It's actually a book written by Hugh Ross, Ken Samples, both who will be here, and then Mark Clark, and they look at the whole UFO phenomena. And they basically, in a nutshell, argue that most of the UFO phenomena can be explained through either some kind of experimental aircraft or meteorological phenomena or something like that. But there's a small number that actually seem like there are some kind of encounters that people are having with alien beings. And their conclusion is that when you look at the nature of those encounters, it looks very much like people are engaged or are having these occultic experiences. And so their conclusion is it's probably that small residual that can't be explained by natural phenomena or, again, meteorological events very well may be demonic encounters. So,
Chuck Metzler, before he passed away, he wrote a little bit and spoke a little bit on his study of alien encounters and stuff. And he
Amen.
Yep.
All right, who's next? Ooh,
I wanted to thank you very much for coming here and setting a great example for the kids, that you
Thank
don't
you.
have to check your mind out at the door by what other people are telling you. I want to tell you guys that you need to continue to keep your minds open. God tells us to seek him with our mind. And that doesn't make you, if people make fun of you because you believe that Jesus is Lord and that there is a God, you know what? We have evidence that our Bible is true, and that evidence can be shown through exactly what we were talking about tonight. Some of it might have gone over your head. Don't worry about that. You guys are young. You have a lot to learn. Your minds are open. But don't close them to just things that society and what your teachers even at school might be telling you, because you have the right to look for those answers yourself. And I want to thank you again for letting the kids know that they don't have to check their mind out at the door, and that science does show us that our God did create this universe. And it makes more sense what you're saying than Charles Darwin. Thank you.
Okay, this is kind of a weird question, but in the interest of reconciling science and the Bible, we've discovered all these primitive forms of humans, like the Neanderthals and Cro-Magnons and such. So does that mean that Adam and Eve were like Neanderthals or a more primitive form of life? Or how does that work?
Yeah, well, if you're really into that, there's a book called Who is Adam that you may want to check out. In fact, there's even a chapter in Building Bridges that addresses that topic. But the way I look at the hominins, so creatures like Neanderthals, Homo erectus, Homo habilis, is that these are creatures that God made that existed and then just simply went extinct. I don't see them as evolutionary predecessors to humans. And it's interesting when you look at the work in paleoanthropology. When evolutionary biologists try to draw the evolutionary trees that connect the hominins, it's total chaos. I mean, there's so much disagreement as to what those evolutionary relationships might be. And when new fossils are discovered or new specimens are discovered, many times it just throws the whole discipline into further chaos. So everybody's going out and redrawing the trees, and they still don't agree with each other. And that, to me, actually is a sign that there's a problem, because in science, if you've got a good theory, when you make new discoveries, it just solidifies and crystallizes things. If you're on the wrong track, new insights just create chaos until you find that appropriate organizing framework. So that, to me, is right away a clue that maybe, thinking about these hominins from an evolutionary perspective isn't necessarily the best way. These creatures did have some emotional capacity, some intellectual capacity, but I don't see them as image bearers. I think that's only, modern humans, us, that display, the image of God. What's really interesting to me is, Darwin was the one who really proposed this notion of human evolution, or really advanced it. And his idea was that as human beings, we only differ in degree, not kind, from the other hominins. So he just saw this gradual evolutionary emergence of humans, where he said, the point where humans appear, is indiscernible, right? It's just, and everything about us is the product of evolution. What's really interesting is that there's a growing movement among evolutionary anthropologists to say, actually, Darwin was wrong about that we're not different in degree, we actually are different in kind from other hominins, and that we stand apart. And so there's this idea called human exceptionalism that's a scientific idea that's gaining a lot of support, where, humans we just stand apart from other creatures. And what people believe it makes us distinct is our capacity for symbolism. We can represent the world with symbols and manipulate those symbols. And that's the basis for language, for music, for art. And we also have what's called theory of mind, where we recognize that others have minds like ours. And we can anticipate what they're thinking, what they're feeling, and we want to start connecting our minds together. And so it's those combination of properties that people think separates us from the other creatures. And I see those as scientific descriptors of the qualities that would be, the image of God. And so it is interesting that even among evolutionary biologists, they are beginning to argue that really there's something special about us as human beings. In fact, I do a lot of debates and conversations with people on YouTube that hold to an evolutionary perspective. And I cannot remember anybody in recent years who would deny human exceptionalism. So I come onto these programs ready to bring up this idea of human exceptionalism and the evidence for it, and there's just total agreement that we really are exceptional. And, it's interesting because, again, what I think defines our exceptional nature is our language capacity. And that's one of the big problems in evolutionary biology today is how do you explain the evolutionary origin of language? And it's just like the origin of life problem. People have these ideas and none of them work. Nobody can, and what's also interesting is that this capacity for language just shows up suddenly in the archaeological record out of nowhere when modern humans appear. This is called the sociocultural Big Bang. It's just like out of nowhere, modern humans show up, and then suddenly there's this capability that none of the other hominins display. So even when people are looking at human origins in an evolutionary framework, you can't escape what appears to be this designed fingerprint.
Does RTB hold to historical Adam?
Yes. Yeah.
Have they dated it?
I don't think you can date the historical Adam from Scripture. I think, and so to me, I just accept the scientific dates, which are ballpark 100 to 150,000 years ago. So that would be, my perspective.
Okay.
It's not. I would prefer the historical Adam to be more recent than that, but
Yeah.
That's what the data seems to suggest at this point.
Older the better. Okay. Any other questions? Oh, yeah. Do you remember it? Did you pray and?
This is something completely different.
Okay.
So, I'm going to ask the question, and then I have some explaining to before you answer it. So,
Sure.
How old do you think the Earth is? Because, in Genesis, it says God created the Earth in 7 days. He created everything in 7 days. And there's people in my family who have conflicting interpretations of this. For an example, my grandpa believes that it was exactly 7 days and that the Earth is much younger than plenty of scientists believe. And for an example, my parents believe that that 7 is symbolically a long period of time. So what are your thoughts on that?
Well, I would hold to the view that your parents hold to, that I think the days of Genesis 1 are long periods of time. And both your grandparents or your grandfather and your parents have a point, because in the original Hebrew, the word translated yom, or day, is yom, and it can mean, similar to how we would use the word day, it can mean part of a day, it can mean time from sun up to sundown, it can mean 24 hours. It can also mean a period of time, right? And so all of them are possibilities. And so the question is, which one fits the text best? And so there's a fairly well-known Old Testament scholar by the name of Walt Kaiser who argues that when you look at the first day of creation in Genesis 1, what you see is that on the first creation day, a day was created. Light is separated from darkness, and God called the light day, the darkness night. So his point is that the creation day can't be 24 hours because on the first creation day, the first day was created. So his argument is that that seems to indicate that it's probably a period of time. Another Old Testament scholar by the name of Gleason Archer made this argument, which I find really compelling, is that on the sixth day of creation, we see male and female created in God's image at the very end of the sixth day. I think that Genesis 2 is expanding on the sixth day of creation, focusing on the creation of human beings. And so Adam is created from the dust of the earth. God breathes the breath of life into him. There is no Garden of Eden when Adam is created. God then causes the garden to grow. Adam is placed in the garden. He works the garden, and then he names the animals. And that process of naming the animals took time. And so when you look at everything that Adam did before Eve was created, it can't happen in 24 hours. And so if you're going to have Genesis 1 and 2 be consistent with each other, then you have to look at the days as a long period of time, or as a period of time.
So a couple more questions, like building on what you said of like, if Adam had to like be naming things, then like it would have to be a longer period of time than a 24-hour day. Then do you think that explains the greater age of some of the early characters of the Bible, like say like Methuselah?
I think there's a different explanation for that. When I was here maybe a couple of years ago now, we were talking about this idea of transhumanism, that through science people think that maybe you could extend human life expectancy by modifying our biological makeup. But part of that is this work in trying to understand the biology of aging. And people working in that area think that they understand the aging process enough that they can actually step in and intervene and disrupt the aging process, maybe even reverse it. So there are people that are literally talking now about extending human life expectancy for hundreds, maybe even close to 1,000 years. And so this is a serious scientific idea. And what's interesting is that to extend life expectancy of animals in the lab, all you got to do is just do some very small tweaks to their biochemistry, and you can dramatically extend life expectancy. So I think that the most likely explanation is that God created human beings initially to live for hundreds of years. And if you read Genesis 6, it says that the only thought in the hearts of all the people was only evil all the time. It was really a bad scene. And God says, I'm no longer going to contend with human beings, and I'm going to shorten their lifespan to 120 years, right? And you see in Genesis, the genealogy in Genesis 11, that the life expectancy of the patriarchs becomes shorter and shorter. Well, you could envision God, it looks like God intervened to shorten life expectancy. So could a God have stepped in and altered our biochemistry to shorten our life expectancy? So I think what's happening in the biology of aging gives us some framework to think about those long lifespans and how the lifespans were shortened just by God creating us to live that long initially, and then stepping in and shortening it. So
returning to the 7 days question, when you said that the word for a day can translate to many different lengths of time, doesn't 7 also have a special significance in the Bible?
Yes, I think it's the number that connotes completeness. Yeah. So there's a lot of things going on in Genesis 1. Part of it is that 6+1 pattern. And you actually see that in the law presented in Exodus, in Leviticus, and Deuteronomy, is when it talks about the Sabbath. God created in 6 days and rested on the seventh day. So you're to pattern your work week, working for 6 days, resting for the seventh day. When you look at the Levitical law, when it talks about working the land, it's worked for 6 years, rests for a year. When it comes to the institution wasn't really slavery, but it was like an indentured servitude. It was 6 years, and then on the 7th year, you granted that person their freedom. So that 6+1 pattern is throughout the Old Testament, and it's predicated on the creation account in Genesis 1.
So, based on what you said, I kind of thought of something, which is then thinking of that significance. Then, like in I think it's Matthew, when it's written the genealogy of Jesus from I think David, right? It's all like sets of 14.
Mm-hmm.
I just realized it's sort of a cool like
Yep.
symbolic thing of like, you know, the sort of destiny of that lineage has been completed. Right. What was my other question? Maybe I'll leave it at that. Other people are curious.
So those were some good questions. All right, one more big kid question. Any other big kid questions? That's all right.
I saw some stuff on dating, how they date fossils and everything too, and then there was the radiation from the sun, and then different levels of the magnetosphere and how maybe the Earth evolved to block those radiation levels from the sun, may explain also how we were able to live longer in the past versus now, because the radioactive energy from the sun actually decays things more rapidly, I believe.
Yeah.
So I don't know if you've heard of that, but it seems like after the flood, that's when the lifespan of humans starts to decline.
Yeah, well, I mean, along those lines, Hugh Ross, who will be here, you know, as part of this series, has this idea that, you know, seems to me to be reasonable, but this is outside my area of expertise. But he argues that there was a supernova event that was fairly recent that could have very well impacted human life expectancy because of the radiation coming from the supernova event, that prior to that, humans would have been able to live longer, and that supernova event and the radiation from that event is still impinging on the Earth, could have very well shortened life expectancy. So that's one idea that's... No.
That too could maybe affect the way we date things now, because the radiation levels and what hit back then may be different. And not to say that, everything was 6,000 years or not, whatever, but that could also play a part in it when trying to disseminate, okay, was it this amount of time or that amount of time?
Yeah, well, that kind of cosmic event could impact radiometric dating for what are called the cosmogenic isotopes. So carbon-14 is a cosmogenic isotope. There's an aluminum isotope and a beryllium isotope that are in that category. So, and in fact, when you look at how people do the calibration for carbon-14, they take into account those types of things, or they try to as they calibrate carbon-14. But for things like potassium argon dating, or the different uranium series isotopes or other isotopes, that kind of cosmic radiation isn't going to change their decay rates. So it can for some elements, but not as a rule of thumb. Well, the rule of thumb is that you can use a radiometric isotope for a factor of 10 with respect to its half-life. And I think the half-life of carbon-14 is like is it 3,500 years or 4,500 years? I can't remember off the top of my head. Let's just say it's 4,500 years. That means you can use carbon-14 to date something that's approximately 500 years old to maybe 50,000 years old. That's about the utility of carbon-14. So if you're going to date something that you suspect is older, you'd have to use like a potassium argon dating. That's a very common dating technique for fossils. There's about 40 different radiometric methods that are using different isotopes, and each one is its own method and it has its own strengths and limitations. But when you look at the ensemble of radiometric methods, you're getting a pretty reliable picture for the age of the fossil record. Yeah.
All right. Okay, one more question. It's good stuff. That last one went over my head, though.
Just a comment on the origin and age of the Earth. Day one, day and night were created. And so we define day and night, or a day, as one rotation of the Earth around its own axis. We don't actually know how fast the Earth rotated around its axis. And so that's one thing we simply don't know. But we also define a year as one rotation of the Earth around the sun, which actually doesn't show up until day 4. So we have actually no information whatsoever about day 1 through 3, how long those took. And I think that's one of the challenges in trying to date the Earth.
Yeah.
I have a question. Do you think that maybe these scientists know that there's a God, but they don't want to admit that they were wrong because they've been living an atheist life for so long?
Well, actually, there's a pretty high level of belief among scientists. I've seen survey data that indicates probably close to 30 to 35% of scientists believe in a personal God across disciplines. So there's actually a pretty high rate of belief. And I think for some scientists, in my experience, a lot of scientists have not even really thought about the God question. You know, we live in a world where people are, it's an increasingly secular world. And so people are just unchurched and grow up in an unchurched, with an unchurched experience and go off to college and live their lives. And, I remember engaging several Original Life researchers a few years ago. I was at an Original Life conference and just chatting with them. And when I told them a little bit about who I was and what I do, they were very interested, actually. And they're like, I've never even thought about this. I'm a scientist. I guess I'm an atheist. So that was the level of thought they've put into it. And so science is very addictive. I mean, when you start getting into your scientific research, it's so fun and it's so all-consuming that a lot of times people just don't pause to think about other issues. And so there's a lot of scientists who just haven't even thought about this. Now, there are some scientists who, are evangelists for atheism, right, and who are really hostile to belief in God. But I think most scientists haven't thought about it. That's just my experience, which to me is really encouraging because it means that if you're able to engage scientists, that you just might be able to make inroads because they just haven't thought about it.
Very cool. All right, on that note, we're going to wrap it up. It's a very good night. Let's give a hand to Fuz. Thank you, Fuz. Very exciting stuff. Great questions. All right. Next week is the ethical questions on abortion, which is the hot topic of our culture at the moment. This is one that we don't want to miss. It'll probably want to be one of the harder talks. George, why don't you stand up? This is George. He's going to be teaching that one. And better him than me. So I want to encourage you to invite your friends, specifically ones that are struggling with that issue or maybe just don't know. And I think that's going to be a very enlightening session. So join us next week, and thank you again. I want to encourage you all to financially support Reasons to Believe. The way that you can do that now is by dropping whatever donation you would want to give in that black box on your way out. The other way that you can give, you can just give to Reasons to Believe directly by going to their website or seeing that good-looking guy in the black, the hat back there. He'll take your money. All right. Thank you so much for joining us tonight. God bless you. Have a good evening.